All right, we have solved quadratic equations, meaning power of 2. Today we're going to look at some higher powers and how to solve them, and today we'll be solving them by factoring. So it's kind of a review lesson, really, with another step added. And so we've learned a lot of different types of factoring. One of the things you won't have to use is difference in sum of cubes, okay? I don't do that when you solve equations. There's an easier way to do that than using those two formulas. So you don't need to know those. Basically, you need to know difference of squares, pulling out a GCF, and the X method. Okay, so just those three. All right. You don't need to write this down. This is just kind of gives kind of a bigger picture thing. When you solve for X in an equation, what you're really doing is finding where it crosses the x-axis. Now this is more of like a pre-calc thing because we get more into graphing there. But in the future, when it says solve or find x-intercepts, find the zeros, that basically means solve for x. It's the same thing. So let's do an example that's not on the worksheet, and then we'll do two examples on the worksheet. So the first example is 2x to the fourth equals 2x squared. Now, it says step 1, move everything to one side, but if you notice on your worksheet, everything is already on one side. Everything is equal to 0, so you don't have to do step 1 on the worksheet. But just like the last test we had, you had stuff on separate sides, you had to move one thing to the other. Make sure you do that for step 1. So in this case, I don't know why I did this, okay? For some reason I moved it to the right. It doesn't matter. You could have subtracted 2x squared from both sides and moved it as long as everything's on the same side, okay? So I subtracted 2x to the fourth. Okay, so make sure you put the highest power first. So put 2x to the fourth first, and then put 2x squared next. Once you get everything on one side, this is basically where you're going to start off on the worksheet. Go ahead and factor. Okay? Always pull out a GCF first. So let's take a look at these two terms. 2x squared goes into both of them, but since the first term is negative, I'm going to pull out a negative 2x squared. That leaves me with an x squared for the first term, minus 1 for the second. And why is the second one negative? Because it was originally positive. So a negative times a negative gives you a positive back. It's the reverse sign of what it started with. Same thing for this one. So you pull out a GCF. Now you have negative 2x squared times x squared minus 1. Now remember steps for factoring. You don't just factor once and leave it. You factor until you can't factor anymore. Is there anything left that can be factored? And if so, what is it? X squared minus 1. How would you factor it? And factor 2.
X minus 1, x plus 1.
Yeah, x minus 1, x plus 1. Let's do this so we don't do everything at once. Okay. So it factors to x plus 1, x minus 1, using the difference of squares formula. All right, so how many factors do we have now that we've broken that down? 3. Yes. No, that's it. We factored it all the way. Here's the first factor. Here's the second factor. Here's the third factor. Okay. So a lot of times on the worksheet, like the first 3, you're only going to have 2 factors. Sometimes you get 3 factors. Sometimes you get 4 factors. So the next step. Actually, before I go to the next step, let me quiz you guys on something to explain this step. What would happen here if x was equal to 0?
Equals 0. Yeah.
It'd be 0 because it's negative 2 times 0. All right, what would happen to the entire... What is 0 times anything?
0. The whole equation equals 0.
The whole thing would be 0, yes. So anytime a factor is equal to 0, the whole thing becomes 0. This is why we set each factor equal to 0. That's our next step. So we're basically going to take each of these things, each of these factors, and set them equal to 0. Okay, so there's your next step. Set each factor equal to 0 and solve. You guys notice that the first one's going to be equal to 0. Some of you might not have seen that, so I'll show you why. When you set the first factor equal to 0, you don't really have to do the work, but let's do it anyways. Divide by -2, right? But what's 0 over -2? Just 0. Take the square root, 0, 0, 0. Okay, if it's just one term, if it's not like plus something, right, like plus 7, it's going to equal 0. So if it was just like, just imagine if it was 7x to the 100th equals 0. I mean, it doesn't matter. You're still going to get x equals 0 because it's just one term. You'll divide by 7, take the 100th root, it's just 0, okay? So you don't have to show your work for that every time. Let's look at the next. Let's see if I can pull this back up. Okay. We're going to set the other two factors equal to 0, though. So, namely, x plus 1, set that equal to 0, and set the other factor equal to 0, the x minus 1. And then you just solve it out. So if x plus 1 equals 0, what is x?
0.
-1, yeah, you have to subtract 1 from both sides. And then for the other one, when x minus 1 equals 0, add 1 to both sides, x equals 1. So you get 3 answers for this. So anything on the worksheet is going to range from 2 answers to 4 answers. You'll have 2, 3, or 4 answers. So I want to do 2 more that come from the worksheet. So the next example is going to be, yeah, because if you read the directions, it says solve for x. So if you were to plug those numbers back into the equation, they would equal 0 out for the whole thing. In fact, I'll show you that real quick. You don't have to write this down. But if we were to plug those back in, if we were to plug 0 back in, for example, into the original equation, we get 0 equals 0. So it checks out, right? If we plug in -1, we get 2 equals 2 for the equation. Checks out. We plug in 1 back, we also get 2 equals 2. So it balances the equation out, the original thing they were given. All right, let's do example 2, which I believe is example 1 on the worksheet. Whoops. Okay, so we got...
So there's only 3 steps?
Yeah, pretty much. This is number 1 on the worksheet. We got x squared minus 5x plus 6 equals 0. What method will you use to factor this?
X method.
How did you know that?
Because there's 3.
Thank you. 3 terms. It's called a trinomial. Tri meaning 3. I know some of you have trouble with this, but this one's pretty easy. You have a times c on the top, 6, b on the bottom, -5. 2 numbers that multiply to give you 6 and add to give you -5 are -3 and -2. All right. So any questions about that x? So that expression right there, the minus 5x, will become minus 3x minus 2x based on what we got there. So lasso all this and move it over. Okay, and then what do? You pull out a what?
GCF.
Pull out GCF for each. The GCF of the first 2 is x. The GCF of the next 2 is minus 2. So what is the final answer?
X minus 2 is
X minus 2.
Yep, x minus 3 and x minus 2. I think we've done this so much that we should know it like the back of our hand.
not equal 0, right?
Yeah, so now that leads us to the, I'll go back to this slide, don't worry. That leads us to the step we just learned now, which is set each factor equal to 0 and solve once it's been factored. Let's go back to this example. So we're going to set x minus 3 equal to 0, okay, our first factor. All right, and then we're going to set x minus 2 equal to 0. So there's our x minus 3 equal to 0. And there's our x minus 2. So the first one you get x plus 3, the second one you get x equals 2, and that's it. So yeah, when you plug it back in, you get 0 for both of them. All right, the third and final example is number 9 on the worksheet. X cubed minus 9x. So remember, always try to pull out a GCF first. In this particular case, they both have an x in common. So you pull an x out, and you're left with x squared minus 9. What method would you use to factor that?
The squares.
Difference of
Subtraction.
squares.
Yeah.
Right? Because this is x squared, and this is a perfect square, and it's a minus. There is no sum of squares. I've said that before. If it was x squared plus 9, you cannot factor that, okay? There's no sum of squares formula. It has to be a minus between. So then you just take the square root of this to get x. Square root of that is 3. So x and 3, it goes x plus 3, x minus 3. All right? If it was 16, x plus 4, x minus 4. Whatever. Now here's the question for you. How do you know when you're done factoring? Like, how do I know I can't factor this
Because
stuff?
that's as low as it goes.
Yeah. If it's, look at the power here.
X.
If it's just x and then a number, it can't be factored. Okay? So now we're going to set all three factors equal to 0.
X equals 0, x equals 2, x equals -3.
Yeah, I think over here on the left I'm going to have to make some room because you can't see it. I mean on the right. All right, yeah, so the first one, check out the first one. It's the factor that we pulled out, the GCF, is just x. Well, when you set it equal to 0, it solves itself, right? Like, you don't have to do anything. It's done. The middle expression, you have x plus 3 equals 0. Subtract 3x equals -3. The third one, you're going to add 3 to both sides, and you get x equals 3. So that's all you have to do for this one. I need to show one more thing because it came up with the other class. And then I'll leave a page of formulas on the board. So here's what happened, and I just want to know what to do unless I showed you this. But let's just say you have x squared minus 7 equals 0. How would you solve that?
Add 7.
Okay. So maybe you can do it. And then what would you do?
You gotta radical both sides.
Okay, you still radical because you have to get... Your answer
X equals
is just going to be plus or minus radical 7. So the point is, when this number is not a perfect square, you still get two answers from it. It's just not a perfect square.
Okay, I'm actually going to write this.
So that's it. We have 10 questions to go over today, and then we'll go over it at the end of class. I will be checking your notes and assignments for the week.